All right, welcome back. We are on Unit 4, limits of day 2. So we're going to kind of push back the schedule a little bit. We are on page 5 of the notes. The problems that you've been given already have had graphs with them, and they've had horizontal asymptotes, had some verticals, horizontals, they've had some holes. They've gone off to infinity, negative infinity, off to certain numbers depending on what the limit's going towards. Now, you're kind of going to be doing the reverse. I'm going to give you information and you're going to actually make the graph so someone would look at it and determine what's going on. So, some things. So, horizontal and vertical asymptotes. So, from the last unit, you're going to have horizontal asymptotes, you're going to have vertical asymptotes in the graph. So, you're going to know that's going to be horizontal when it looks like this. The limit of x is going towards infinity or negative infinity. So if it has one of those with the x is going towards, then the y value is going to have a number. For example, so the limit as x approaches infinity is going to be 2. So these are the x values and those are the y values. The x values are going towards infinity, so positive or negative, so to the right or to the left, and the y value is going towards a specific number that is a horizontal asymptote. A vertical asymptote is going to occur if it's the opposite. So you're going to have the limit as x approaches some number, so a specific number, and the y value goes towards infinity or negative infinity. So for example, the limit x approaches 3, maybe on the left, maybe on the right. And it has an infinity symbol for the y value. Alright, so then we get into vertical and horizontal asymptotes. There's going to be a value. So you're going to have an open circle for a limit. And I'll explain that in a second. And you're going to have a closed circle when there's actually function notation. And I'll show you the difference in how that looks. Okay, so there's values. So open circles or closed circles. Open circles for when you have a limit. So it's not the exact number, but it's going towards that. So if it's a limit of x is going towards a number, and y is going towards a number, that's going to be an open circle. If it's function notation, that's going to be a closed circle. So, for example, 2 different problems. If you do the limit, as x is approaching -4, maybe on the right, and for 5. So the x value is going towards a number, specific number, and the y value is also going towards a specific number. So if you have number and number, that means you're going to have an open circle pretty much like at that point. So at -4 and 5, you'd put an open circle, and you need to remember the graph is going on the right side of that. If you would have something like the function notation of 3 equals 9, this is function notation. You would have a filled in circle or an exact value. Okay, x value, y value. So you'd have the order pair at 3, 9. Put in a closed circle there. All right, so today you're going to work backwards. You're going to be given all these properties of the function. So there's going to be a list of them. We're going to be able to recognize whether you have a particular limit has a vertical asymptote, a horizontal asymptote, or a value. All right, so first of all, I would go through and just identify HA, VA, value, so you can get this information on here. Okay? All right, so anytime you have the limit going towards infinity or negative infinity, and then you have a number value. So If it's going like on letter A, it's going towards negative infinity. The x values are going here. Whoops, I didn't mean to scratch that out. But going towards negative infinity with a number value, this is a horizontal asymptote. Let's check out letter B. Nope. C, nope. D, nope. E, nope. F, here we go. The x value is going towards infinity. The y value is going towards 0, so this is a horizontal asymptote. So I'm just working on identifying them first. Letter G, same thing. I have another horizontal asymptote here. Letter H, no, and letter I, no. Alright, so A, F, and G meant you had horizontal asymptotes. I'm not graphing it yet, I'm just identifying them. On letter B, it's the reverse. If the x values are going towards a number, and the y values are going towards infinity, then you have a vertical asymptote. So vertical asymptote here, I have number and number, so this number and number for D, nope. E, a number with an infinity, so that means you have a vertical asymptote. G, we already did. H is a vertical asymptote again, because you're going towards infinity, a number value from that. And I are two numbers. Okay, horizontal asymptotes we did, vertical asymptotes we did. Now the values, we look for a number for x and a number for y, so that's a value. X and y, so this is a value. I is a value also. So all of these values are for open circles because there's no function notation. So open circle for C at -3 and 6, that'd be an open circle. And then from -3 and 6 on the right, that'd be another open circle. So there's would be no closed circles on this graph. All right, so now we're going to take this and take a simplistic kind of just some basic ones and look at the same thing. Identify horizontal asymptotes, vertical asymptotes, and get them on there. So negative infinity, infinity for x, value for y, that's a horizontal. The reverse is a vertical. Letter C, a number with infinity is a vertical. And letter D is a horizontal. Alright, so when you're graphing those, put verticals on vertical asymptotes should be graphed first. Because horizontal asymptotes don't always go through the entire graph. You'll see, especially for these, that they are going to stop at the vertical asymptote, so it's going to be important we get the vertical asymptotes on there first. Alright, so my vertical asymptote is at my x value of -1 for this, and my x value is at -1. So when we graph this, -1, my vertical asymptote is here. Now, my horizontal asymptote, it says the y value is at 0, so that's my horizontal asymptote. My horizontal asymptote again says y is going to be the 0, so my vertical asymptote was at -1, but my horizontal asymptote goes through 0. Okay, so I have vertical at -1. My horizontal at y equals 0. Now, the thing is just to get the graph on there. Okay, so we're just doing a sketch. You're not asking to actually get real actual points on here unless you have a value. So in this one, this is kind of like your ordered pair. You're going towards negative infinity for the x's, and the y values are going towards 0. On letter B, the x values are -1 on the left is going towards negative infinity for the y's. So get the graphs on there, get the information on there for those verticals first. So for -1 on the left side, I need to know whether the graph is going up or down, and because it says negative infinity, I know this where it should be down. The left side of -1, the graph should be going towards negative infinity. For the right side of -1, the y value should be going towards positive infinity. Okay, so vertical asymptote, the right side of -1, the values goes towards positive infinity. Alright, and then we kind of fill in the rest of the graph from there. So going back to this, so as the x values go towards negative infinity, the y values go to 0. And since the graph is down here, I know I'm not going to put part of the graph above it, so we only have this one part that scoots like up along here. And for letter D, we haven't done yet, it's going towards that. For the positive infinities for x's, the graph is going out, the graph is going out towards 0. Alright, so that's page 5. So go ahead and turn the page, go to page number 6, get the top section for example 3, figure out the horizontal, vertical asymptotes and the values, and we'll go from there.